get started. Cool. Would you like to introduce yourself?
Yeah, absolutely. So for those of you that don't know me, my name is Garrett Kramer. I'm currently a manufacturing engineer at the Boeing company here in St. Louis. I've been with the company for about 7 months now. So I just graduated college, undergraduate in May from the University of Louisville in Kentucky with my bachelor's in chemical engineering, actually. So obviously we'll get into quite a bit more. I understand there's some questions. So I'll tell you guys kind of quite a bit more with that. My experience with FTC and robotics in general, I was a participant or I was a member of our college's K through 12 outreach team in which we went to different high schools and different churches and things like that and did partnerships with, I guess, communities that don't have kind of the resources that a lot of different schools have and performed activities with them and kind of, try to generate STEM interest and things like that. And so part of my what they called a partnership was every single week I went to a high school in Kentucky and Louisville and mentored their VEX robotics team and then got some experience with their first teams as well. So I got about a year-ish with VEX and then about half a year with FIRST, just scratching the surface with FIRST. So looking forward to, kind of learning some more with you guys and telling you more about myself and how I got to where I am.
Yeah, I can go next. My name is Andrew Reddy. My friends just call me ARC, and I'm a senior from Marquette High School. And next year, I'm going to be a mechanical engineering undergraduate. So, but yeah, that's
Awesome.
me.
Where?
I'm thinking I'm probably going to go to S&P
Right.
because just because of financially and stuff. So that's what I'm looking at.
Awesome. Congrats. That's huge.
Thank you.
I'll go next. My name is Ashish. I'm one of the co-captains of this team. I'm a senior this year, and next year I hope to go into aerospace engineering.
Awesome.
Yeah.
You know a school yet?
I haven't decided yet, but I'm looking between a few. Some of them are like UIUC and Purdue. So.
Awesome. Awesome. I'm very familiar with UIUC. So that's great.
Awesome.
My name is Emily Laurie. I'm a junior at Marquette, and I do the documentation stuff for the team. So, yeah.
Right on.
Hello, my name is Samir Farouk. I am a junior, and I do all the programming for the team.
Well, you got the hard job, in my opinion. The fun job. Well, nice to meet you all.
Well, can we ask you some questions about your job and just like your
Absolutely.
experience? Okay, cool. So, what exactly is a manufacturing engineer?
Yeah, so that's a great question. And that's something that I had no idea about when I first started at Boeing. So I guess kind of going back into things. So I graduated chemical engineering and was not interested in doing chemical engineering, to be honest with you. I knew that I wanted to be an engineer of some sort and knew I wanted to solve problems. And so part of kind of my train of thought with getting a job was, I just want to get into the company. I can find whatever job I want permanently later after X amount of time, but I just wanted to get in the company. I knew that I wanted to do something with production engineering. I knew I wanted to stay within that kind of realm with manufacturing. And so manufacturing engineer is, I would say, more mechanical. So if you think of like the big 4 or 5, the chemical, mechanical, industrial, aerospace is even more mechanical. Let's see, biomedical, things like that. It's more mechanical in that I'm working with 3-dimensional models. I'm working with what they call work instructions. And so basically a way to think of a work instruction is if you're the mechanic or you're somebody who's putting the plane together, you're looking at these work instructions and it's telling you step by step with a 3-dimensional model exactly how to put the plane together, exactly where all the screws and fasteners should go, what the panels are, things like that. And so we're basically doing this new process for this new plane, this new refueler that we're working on for the Navy. And we're doing what's called model-based and model-based instructions, MBIs, they call them. So it's completely 3-dimensional modeled, and it's the first program of its kind that's doing it. And so essentially the way that we're working it is the mechanics that are going to be on the floor are going to have like little iPads in their hand, and they're going to be able to use their finger and score around the entire 3-dimensional model to see, where things go. So say you've got a bolt that goes in, then you've got to put a nut on the backhand side. They get to move the model around to see where exactly that nut goes. So things like that, it's kind of, the future of where the aerospace industry and manufacturing is really going. But a manufacturing engineer, we do a lot of development, I would say, for manufacturing. So the way to think about it is we're not doing process improvement, really. We're not doing the design of the plane. We're kind of in between. So we take what the design engineers put together. Say somebody creates a brand new plane, right? We bid it, we get approval for it. We're the people who take the design that they have and we create all of the instructions on the build order. How is this thing going to be built? What do we need? How many people do we need? So we kind of are the people who figure out how this thing is actually going to be built. And then we put together the work instructions, we put together kind of the whole plan. They call it planning. So a couple big words that we use are like model-based production planning. So using a model, using simulation, using VR and AR, augmented reality, to kind of see things in real life. We work with what's called the environmental health and safety. So people with ergonomics. Can the mechanics actually pick up this wing, or do we need hoisting? If we need hoisting, what kind of hoisting? So it's all these kind of planning things that go into it, as well as simulations to see step by step how this thing's going to be put together, where it's going to be produced, things like that, factory layout, things like that. So I didn't know much about it at all, and I kind of, learned it on the job, which is another, I think, very big lesson. Is you can go through school, they can teach you mathematics, they can teach you biology, but it's really, it comes down to on the job training, really. And you could take a science degree, you could take a math degree, and you can go into working in, production and manufacturing, and they'll teach you everything on the job, and you can do better than anything. So it's really what college teaches you, is it's really that mindset of, I can solve a problem. Here's how I solve a problem by using this, essentially. So yeah, it's interesting, and it's a lot. It's a big scope. It's a really, really big scope of work. But there's a lot of different people. So like I'm a manufacturing engineer for structures is what they call it. So I actually do like the big metal pieces that go on the plane. So I'm not worrying about wiring or electrical or anything like that. I'm specifically dealing with the big structures.
Sounds cool. I didn't know that was like a career, but that sounds really nice. So I was just wondering, how did you go from majoring as a chemical engineer to having like a job in a different, like, I guess, field?
Yeah, and that's a really good question. That's something that, a lot of people don't know or teach. Really what it comes down to, and if you look at a lot of job postings, it comes down to a certain prerequisite. Did you graduate with a STEM degree? Science, technology, engineering, mathematics, that whole spiel. Did you graduate with X GPA? And a lot of companies will say, oh, GPA doesn't matter. You just need to get as best as possible, right? But a lot of these companies, like I know Boeing specifically, they publish, you have to have a 3.0 to apply. But realistically, you need to have around a 3.3 to a 3.5 to be considered. So they have like these GPA requirements. So it's first, did you graduate within some type of engineering or mathematics or STEM degree, GPA? There's all these prereqs, right? But what they really look for is they look for people who can solve a problem. So if you can meet the prereqs, essentially, which is, the standard set of questions that you answer on a job interview, they give you an interview and you can kind of talk your way through it and demonstrate, the ability to solve a problem beyond what you were taught. So for me, chemical engineering, when I was doing interviews and applications and things like that, I did my internships actually in automotive, and I worked for BMW manufacturing, making cars in South Carolina. And so I had all this experience as a quality engineer there with process improvement and, working with the products and working with management and things like that. And you can kind of draw on all these experiences, whether it's being a lifeguard, whether it's being a teaching assistant, whether it's working at McDonald's. There's all these certain things that you can pull out of it. So instead of saying, oh, I make fries, right? You can say, I worked on my customer interactions. I worked on my communication skills. Like you can pull all these kind of engineering skills out of it and really kind of market yourself, I would say. So for me going chemical engineering, I liked chemistry, I liked math, I kind of put them together. It was that simple for me. when I took a job at BMW, it was kind of the same thing. I wanted to go to that company no matter what it is. I just want to get there. And that was like my stretch goal. That was like the one thing that I wanted to do. And so going into manufacturing was actually a blessing during internships. And I highly recommend internships because you either know what you want to do or you know what you don't want to do. There's really the two opposites. You either love it or you don't. For me, manufacturing was something I fell in love with. And so I kind of knew that that was something I wanted to do. So during interviewing, I had this process engineering background, this thought, this mindset of I can improve something. I can look at a process and I can see this is a way to make it better. This is a way to standardize it and make sure that there's no errors here. But then I also have this chemical side of things, this engineering side of things. And so kind of combining them, I could say, well, I've got this process engineering mindset where I can look at a process and really improve on things, but I've also got this chemistry background. So I could work in the materials department and work on new paint coatings. I could work in the chemical processing area and make the chemical processing or how we paint airplanes. I could make that better. So it's kind of just taking, you know, what you've worked on in the past, the experience that you have, and really trying to say, here's what I can do. Here's where I can use my background and what I've learned to benefit the company, essentially. So again, kind of full circle here, you can apply for any job that you quote unquote qualify for. And that's meeting the bare minimum restrictions. That's saying that you're a good candidate. But then once you finally get into, you know, what you're passionate about and what you actually want to do, whether it's working at a hospital as an industrial engineer doing process optimization with how they hand out medications or how they store gloves or how they turn over operating rooms, or whether you want to work in automotive, you can kind of take what you've learned, whether it's time management skills working on homework, or whether it's communication skills, where you had to give presentations and you worked at McDonald's at the same time and you were able to take what you learned in school and directly apply it to how you speak to customers. There's all these kind of things that you can word in there somehow that will really let you take your education, no matter what it is, into anywhere. And again, it kind of comes down to, you know, what you're passionate about. So I could have gone back and I could have changed my major and gone industrial, but regardless, an engineering degree is an engineering degree, a science degree is a science degree, and you can kind of take that avenue and spin it however you want. So I know a long-ended question, but I think there's a lot there to unpack. I think there's a lot there to learn. And there's no right or wrong answer for it. There's no, if you get chemical engineer, you can only work at distilleries or you can only work in oil and gas. So it's kind of taking, you know, what you learn and applying it to what you're passionate about. And there's jobs everywhere for everything, whether it's aerospace, whether it's automotive, whether it's medical. You can really do anything with an engineering degree, which I think is, I mean, I'm biased, but I think it's one of the best degrees you can get because of that. So absolutely.
So what's like the process of like going from, like learning something new at an actual job? Like how hard is it? I mean, it doesn't have to be hard, but how like different is it, I guess, to learn something while on the job? Is it like stressful, or how do you like go about it?
So the big thing is when you come into a company. So for me, coming into Boeing as a manufacturing engineer, I had zero three-dimensional model experience at all, whether it was like SolidWorks or CATIA or any of that 3D modeling software. I had zero experience with it. So each company is going to do things different. BMW did things different than Boeing does it. BMW dealt with all two-dimensional drawings. They dealt with looking at a piece of paper, right? And they're so keen on, we're making 400 cars a day. We're doing this day after day after day. Boeing is, we're making one plane every month, right? So things are different. There's a lot of issues that come in, things like that. So regards to software and actually learning techniques and things like that, they're going to teach you it all. The biggest thing that I learned was to find a mentor and somebody who's above you who is proficient in that area. So for instance, I knew very little about production engineering, which is kind of process improvement as a whole. It is including the industrial engineers, the manufacturing engineers, the process engineers, kind of all the people that it takes to go into making production happen. And I only knew of really one avenue for that. So finding somebody in your company or in your job, whether it's McDonald's, finding somebody who's a manager who knows more about You know, here's where the fries come from. Here's where the oil comes from. Here's why we use this oil and not this oil. You know what I mean? Kind of looking at things differently, finding somebody to help teach you that kind of stuff, and really being optimistic to learn, being eager to learn. And it's interesting because once you start showing your dedication to learning and showing that you're open to learn, and looking at projects that you get more as a learning opportunity rather than getting something done, it really gets people's minds going, and they say, you know, this kid is really coming up and this kid can really do something beneficial for our organization. So I want to tell him more. I want to teach him more. And as long as you're open to learning like that, they will teach you all you need to know, whether it's your manager, whether it's a colleague that you're working with on the team. It's stressful because you come into a company, you know nothing, right? I had to learn. So with Boeing specifically, they do things so much different than any other company because you work on contracts, right? The US Navy gives us a contract for 40 airplanes and they give us a budget of $50 billion, right? That $50 billion is set up between every single person. You get an allotted set of hours for this job, things like that. So it's hard because you've got to log your time and it's in a certain system and there's certain charge codes. It's all so complex at every company. But the big thing is as long as you're open and receptive to learning, they're going to teach you everything that you need to know. Whereas you think of school, they're going to give you read chapter 1, read chapter 2, where it's just kind of like, you know, get this well-rounded knowledge type of thing. Here on the job, they're going to say, schedule a 30-minute meeting with me. Let's go through this. I'm going to show you how to open up a model in SolidWorks. I'm going to show you how to manipulate a model in SolidWorks. I'm not going to just say, here, go look at this course or Google it. I'm going to actually sit you down and I'm going to look over your shoulder and I'm going to show you how to do it. And I'm telling you, people care, and people, no matter what company you're at, they're going to sit you down and show you this kind of stuff. So as far as learning goes, there's always ways to learn, and people are going to be extremely optimistic to show you things, or not optimistic, but they're going to be super dedicated to showing you the way of things, because people who are on the same page in a company is going to obviously make the company a lot better. So it's more beneficial for them to teach you than for them to not, in a way, if you kind of get what I'm saying. Does that answer your question, or you want me to take it a different avenue?
Yeah, that answers my question. Thank you very much.
Okay. Yeah, absolutely. Absolutely. And again, that's something going from high school where you're in 8 classes a day, you've got 8 periods, or however your guys' high school is structured. And you go to college where you might have 1 class on a Monday and 5 classes on a Wednesday, and then 2 classes on a Thursday. And it's kind of structured a little bit different. And that kind of helps with time management. You'll have more time to go to the gym. You'll have more time to eat, to sleep, things like this. So it all kind of helps you develop to this person where you get to kind of structure your time of how you learn. You get to structure your way of learning. And again, finding study partners and things like that, finding people who push you and help you learn and things like that is a life lesson to take to your job as well, and something to talk about in an interview. So there's all sorts of things throughout college. Yeah, it's just another 4 years of classes or 3 years of classes or whatever it ends up being. But it's really about being open to learning and looking at things rather than, oh, I'm just reading chapter 1, rather than, oh, I'm learning about mass and momentum, say for physics or something like that. How can I apply that to an airplane? Why am I learning this type of thing? So yeah, I would say biggest thing there is not to stress about, oh, I'm going into a new job, I don't know how I'm going to learn. Before it was, here's what you need to learn it. They're going to be patient with you. They know you're coming in with little or no experience. They know that you're not going to know anything internally, and they're going to set you up on that. So yeah, absolutely.
So I have another question. So would you say that like an engineering job isn't all about engineering, but it's also about like funding? And because I've done a job shadowing somewhere called Lincoln Technology. So I've looked at how they talked about how it was more of like it wasn't just about engineering. So they did like image processing stuff. It was more about, I mean, they were also a small company, so they also had to look at like where would they get the funding, how would they like reach out to other people to share this technology and stuff like that. Would you say engineering isn't all about just engineering? Would it be like everything combined?
Yeah, and again, that kind of depends on your job position. and kind of where you are. I would say if you're at a smaller company, more of like a startup, something where, you know, it's not as developed and there's not as many people working, you're definitely going to be tasked with working through the entire, what they call the product life cycle, coming from where you're getting your raw materials, how you're going to produce it, how you're going to get it to your customers, and who are your customers. Now, within Boeing and within most of the defense industry, there's what's called Phantom Works or Skunk Works, which is their like top secret design studio. It's where they come up with all these new products. And my reference for this is those people that work there are going through all of this. They're designing a product. They say, oh, well, we're going to come up with a new type of helicopter that's going to have 4 blades instead of 1, right? And then they look at, well, how much is it going to cost me to get 4 blades? Where am I going to get the blades for? Where should we produce this? Why should we produce it here versus here? Who's going to be our customer, right? So if you're within an organization that, you know, designs and develops products, or it's a small organization, you will be doing all of the product life cycle, like they like to say. But for me, like in my job, I'm only looking at taking this product that's already been developed. It's already been, all of the back end and the supplier stuff has already been done. And I'm working on taking it from a concept to production. So it all depends on the job that you're in. I would say engineering is kind of a flexible, a fluid term. To me, engineering means, you know, working through problems, solving problems, working through issues. And it's kind of taking this team, this collaborative mindset that you have, that you need to work with other people. And working with other people means working on cross-functional teams is the word that they use. Meaning it's not just a group of engineers. You've got people from HR, you've got people from finance, you've got people from safety, you've got people from tooling. You have all these people. Say you're trying to design a new production system. Well, you have to have finances budget in or input in, because you got to figure out how much money you have. You have to have safety to make sure everything is going to be produced safely and the mechanics aren't going to be at risk, right? So you yourself might not be doing all of the safety work or all of the budget stuff, but you will be having those conversations with people and the knowledge to pull people in that do have that knowledge. So I think that's another key character trait that engineers have, especially good engineers, is the ability to know that you don't have all of the specialties, that you're not an expert in budgeting. You're not an expert in supplier quality, but you know exactly who is an expert in that. And instead of saying, well, I know it, I can talk about it, I'm going to pull somebody in who knows way more than me, and they're going to talk about it. So you will be doing stuff with it, but it all depends on, you know, how tasks are divvied out and how the team is set up and things like that. So absolutely, I would say there's a lot more to engineering than designing something. It all just kind of depends where within the life cycle of a product that you are. So absolutely.
Is there a reason you personally chose like a bigger company to work at than maybe something smaller?
Definitely. And going with that, there's a lot of people that say, work for a smaller company, you won't be a number. You'll be more than a number. And, you know, that's kind of something you got to think about, especially being at a bigger company. I would say the benefits of a bigger company is you're going to have way better benefits than if you're at a smaller company, meaning working for like a Google versus working for like maybe a smaller company that's only in St. Louis. You're going to have the nationwide benefits. You're going to have companies that know Google, know the employees. So if you wanted to go to another company, you've got, oh, I worked at Google. You know what I mean? It's kind of like a chip on your shoulder type of thing. Working at a bigger company, there's a lot of benefits to it. There's a lot of ways to grow. A lot of career transformations you can make. Say you don't like manufacturing engineering. Oh, well, I can go be an industrial engineer. I can be a quality engineer, or I could be a design engineer working in wind tunnels, right? If you work at a smaller company, you might not have those opportunities because say there's one person that works in that position for 25 years. But if you're working in a bigger company, like say Boeing, if I wanted to work as a manufacturing engineer, which is a very general term, I could go anywhere in the world as a manufacturing engineer and work anywhere on any team that I wanted to, any product that I wanted to, anything like that. So there's obviously benefits of working at a smaller company, right? The pay might be a little better. It might be a little worse. The benefits might be a little better. They might be a little worse. things like that, recognition. I would say workload. You might get more of a workload at a smaller company than you would at a bigger company. Your statement of work, you might, like I said, you might be doing product development, product design, where you're designing the production line and you're trying to find the company or the customer. Whereas at a bigger company, you're only doing a little stage of that. So there's definitely pros and cons to all of it. And, you know, everybody has their own opinion to it. Personally, why I chose to go to Boeing, I knew that I wanted to, I knew that I was so young in my career. I'm only 23 now. And I wanted an opportunity to kind of take my career wherever I wanted to, essentially. If a position opens up in California, I want to be able to have the opportunity to go to California versus a smaller company. Maybe you'll be living in St. Louis the rest of your life, right? So it's kind of the opportunities that come up from being at a bigger company. It's kind of the, yeah, I would say the opportunities, honestly, the opportunities that you have for career growth, because at such a young age, you don't know where your career is going to go. You might like manufacturing engineering now, but maybe in the future, you'll want to be at a more stable desk job where you can do coding, per se. And maybe you'll want to work from home, and you can work from home as a software engineer, right? So everybody's career path, family happens. Maybe you have a kid, and maybe you can't be working at work so long. So maybe you take a career change or something like that, right? So there's a lot of flexibility and opportunities that comes with being at a bigger company versus maybe a smaller company.
Could you tell us more about your college experience in STEM?
Absolutely. Yeah. So for me, actually, it's kind of a funny story. I went into college pre-dental, biology pre-dental. I wanted to be a dentist. And within 2 weeks of classes, just did not like biology, just did not like my classes that I was taking, didn't like the professors, the people, things like that. Quickly realized that I was passionate about math and engineering and things like that. So I kind of took the more chemical engineering route because I was passionate about chemistry. Being at the University of Louisville where I was, and it's probably similar and different at different schools, where you're at S&T, which is primarily a STEM-based school, I would say. Would you say that as well? Yeah. So it's more of a STEM-based school, whether if you're at, like, say, Michigan State or University of Missouri, you know, one of those like really big schools, you're going to have people from all over. I would say being in a STEM major, obviously you're not going to have the school life balance of, say, a business major, where a lot of business majors don't have classes on Fridays at all. You're definitely gonna work as a STEM major. You're definitely gonna have harder classes. You're gonna have more homework, things like that. But I would say genuinely, you only really have to go to school for 4 years. If you're maybe a business major, you might have to go back to get certifications, or if you're a medical student, you might have to go to medical school. So I would say really 4 years. It's going to be 3 or 4 hard 4 years, and you're going to have a lot of work. You're going to be studying quite a bit and not a lot of playtime, but it's definitely worth it. I would say you learn a lot from being a STEM major, in that you learn kind of your priorities. You know, a lot of people have fun partying, and that's a great thing about college. But you also learn that if you're passionate about engineering, you're passionate about learning, you're passionate about, you know, wanting to be somebody who's successful in life, you'll kind of change your priorities, and you'll realize what you want in life, really. I would say as a STEM major, it was good. It was great, actually. In a way, as an engineering major at a school, you're kind of at the top of the social class, I would say, meaning that people tend to look at engineers as the smart people in school. And so that it's kind of nice having that as well. You do work for it. Obviously, it's a title that you work for. There's a lot of benefits that come with it. There's a lot of hard work. You'll be studying quite a bit on weekends and things like that. But like I said, if you're passionate about it and you find something that you like, it'll be pretty easy for you. And you'll see, I would say, going through college, your freshman year is kind of tough in a way, in that you're trying to figure out that change. You're trying to, you know, maybe you move to a new city. Maybe you live with somebody that you've never met before freshman year. All of these experiences kind of contribute to, you know, a different feeling, something that you're not used to. And then kind of once you get into your sophomore year, that's kind of where they push you. And then your classes get, you know, relatively difficult for that. And that's kind of like the hump, I would say. And once you hit like the end of your sophomore year, things start to coast downhill, I would say, as far as difficulty goes. And for me specifically, my sophomore year was the hardest. And that's usually when I took like calculus 2 and calculus 3. And then past that, you can really tell that professors care. And I would say once you're in your junior year, probably like 98% of the kids graduate. And not all of that is because of hard work. I would say it's because if you show enough care and you show that you want to be there and you want to learn, professors will pass you and they will give you opportunities to get your grades up. It's not like you're in high school, you fail a test, you're screwed. Maybe you get an F in the class. It's like the professors will give you opportunities to, get your grade up and learn. And they're really, really cool. They're really passionate about what they do. And again, I'm speaking because I've had so many different professors in my life. There's always opportunities to see them during office hours and go in when they're done teaching or things like that. And with the college class layout, they're only teaching, say, 2 classes a day. So between those 2 classes, they're just sitting in their office. So you can always go there and ask questions. And there are always study sessions and things like that to kind of help with people. And there's all sorts of resources to kind of learn and help you out through your journey. But I would definitely say it was a great experience. It's one that I'll never forget. And it's something that's taught me a ton of life lessons with how to manage my time, how to talk to people, how to study, how to, focus, things like that. And especially working from home now, it's tough to focus. And so having those experiences of, going to the library to study versus sitting in my dorm room, things like that, it's little things. It could kind of, it matures you. It sets your head right, gets you ready. So absolutely. Does that kind of answer your question? I know I keep talking quite a bit, but there's just a lot to all these questions.
Yeah, that answered it. Thank you.
Is there anything else you're wondering about there with the kind of the college life?
I think you encompassed almost everything that I had questions about. Thank you.
Awesome. Absolutely.
Well, I mean, I'm going into aerospace, and my career path. My career path. I've seen how it's similar to manufacturing. I've read about that, and I wanted to hear about your college experiences, but of course you've talked about it so far. So.
Yeah, no, I guess at Louisville they don't have aerospace engineering, and there's a lot of schools that don't. For us, it was kind of the big 5. It was industrial, mechanical, chemical, biomedical, and civil. So we only had those. We didn't have any derivatives. Like we didn't have like petroleum engineering or nuclear engineering or anything like that. So for us, if you wanted to go into aerospace, you'd either be, chemical or manufacturing or not manufacturing, mechanical or civil or anything like that to kind of, and then take a career path in that kind of option. I would say I didn't see myself my freshman or sophomore year in aerospace. I wanted to be in automotive, and especially once I had my internships, I fell in love with it, and I wanted to be in automotive the rest of my life is what I thought. The big thing with my decision to go aerospace over sticking with BMW was, again, opportunities. With BMW, there's only one production plant in the United States. So kind of going into that smaller plant vibe, if I wanted to move up in the ranks at all, I would have to wait for somebody to either retire or for somebody to quit or to move to a different job, which is tough because people don't like to do that. People don't like to take career changes. And so I kind of sacrificed, my love for automotive for opportunities at a bigger company where I can travel where I want, where I can, live where I want, where I can take whatever job I want. I would say the aerospace as a whole, it really challenges your morals, I would say. It's tough for me, especially working in the defense industry, making a plane like, say, an F-18 or a bomber, having that kind of moral behind you that's like, well, I'm making something that's going to be killing people. It's kind of tough. But once you look into it, like the product that I'm working on right now is called MQ-25. It's the first autonomous refueler for the Navy. So it's completely carrier based and it's going to be refueling the fighter jets. And so something like that is super cool because it's kickstarting the autonomous program for Boeing. So it's kind of kickstarting, I would say, the model based, the drive towards 3-dimensional the drive towards augmented reality, the drive towards autonomy and things like that. But there's also the commercial aspect of things where you can make commercial jets and things like that, or you can make satellites and things like that. So there's a lot to the aerospace industry. And I think it's absolutely fascinating working on planes and working on things that fly. I mean, making things more dimensional than just flat on the earth, I think is fascinating. And also with aerospace, they do stuff with submarines and boats and things like that. So there's a lot of avenues that you can go with it. And one really cool thing is you pretty much have job security too. Especially if you get a security clearance, which some of the positions require a security clearance, which is just a really in-depth background check, not by the company, but by the government. And basically it allows you to get access to top secret or highly secret information that people don't know about, which having information that nobody can know about is kind of cool. And knowing about a product and working on products that nobody has ever seen before, nobody's ever touched before is pretty cool. And you don't really get to do that in automotive. You don't really get to do that in medical. You don't really get to do that in a lot of other industries. And there's a lot of really cool stuff to it. It's really, 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 really complicated stuff, and that you're working with not a $50,000 car, you're working with a $500 million plane. And one wrong move could total a $60,000 panel. You know what I mean? So you're working with really, really complicated stuff, and you get a ton more responsibility. And that was kind of one thing that I pitched in my interviews was, you know, I've had this production engineering, this manufacturing experience, but I want more responsibility. And again, that's something that a lot of people don't want, is more responsibility. And that's what the aerospace industry will get to you. It'll get you that really, really cool feeling where you're working with jets and planes that carry people and people's lives depend on it. And it's a cool feeling getting to walk around and look up and see planes everywhere. And it's cool. But yeah, throughout school, I had zero experience with aerospace. I didn't do a job. I didn't do an internship. I didn't do research with aerospace. I did nothing with aerospace. It was kind of something that, you know, my sister's going to be a pilot. She's in school to be a pilot. And my grandfather was a pilot. So kind of being around planes growing up kind of sparked that, I guess. But yeah, it's all about what you're passionate about. And again, find what you're passionate about learning wise, whether it's, I really like physics and electricity. Say I want to be a mechanical engineer, or I really, really like airplanes and I like things that fly. I like rockets. I like aerospace, or I really like electricity and I like coding and I like programming. So maybe I go electrical engineering or computer science. Or say you want to work on, you know, structural design and you like buildings and roads and bridges and things like that. Maybe you'll go civil. Or if you like biomedical, if you like medical field and you want to do stuff with prosthetics and machines and things like that, then maybe you go biomedical. And you could go to med school with a biomedical engineering degree. You could go to and do anything with that. So I guess my first advice would be to find what you're passionate about learning wise, whether it's you want to learn about cars or things like that. And you do mechanical or, you know, any kind of route there. And then my next, I guess, advice would be find internships. If you think you're passionate about cars, you think that you want to work with cars, get a job working with cars. See if that's really something you're passionate about, right? And engineers are not the people who work at, you know, the auto zone down the street. Engineers are not the people who work at, you know, Jiffy Lube changing oil. Engineers are the people that are designing the cars. Engineers are the people that are working on building the cars. And so get a job where you can experience kind of the behind the scenes before it even touches the customer. Get a job working at a manufacturing plant or a supplier or something like that, and see if you enjoy that experience. And that'll teach you a lot. I myself, I did 3 internships because I was required to do it, but I know people that have done an extra year of school because they've done so many internships. So that's the way to do it, where you're not a full-time employee, but yet you're still getting paid as a full-time employee. You're getting the experience of a full-time employee and the benefits of a full-time employee while you're still learning and still in school. And then the next thing is, once you find out what you're passionate about. So like for myself, I was passionate about chemistry. I was passionate about math. I loved learning about it. And then I found out I was passionate about cars. So looking at, like, oh, I could do stuff with, you know, metal in the cars. I could do stuff with the painting of the cars. And that's kind of taking that chemical aspect and the automotive manufacturing aspect and combining them. So you kind of take your life experiences, whether it's working at McDonald's or you take your education and you kind of combine them into what you think you're passionate about, and then take it that step further and work in that area. So you don't have to know what you want to do. You don't have to know the industry that you want to do. Just at this point, focus on, what you want to learn, what you're passionate about learning. And that's the cool thing about college versus high school. Is high school, you're required to do these classes. You have to do math 1, you have to do math 2, you have to do history. In college, you don't have to do those kind of things. You only do what's tailored towards what you want to learn and the classes that you want to take. And so really take advantage of that and, spark your interest in a certain industry or anything like that. Yeah, I'm looking at the questions that she provided. It was, I think we've hit most of them. I think the one that we haven't hit yet are kind of like what I like most about my job and what the least thing that I like about my job is. So as a manufacturing engineer, there's, a lot of stuff on the work scope, and this is, I guess, production engineering as a whole. The thing that I like the most is it's something relatively different every day. So I'm working on I don't have anything pulled up. No, I don't. I'm working on something relatively different every single day, in that maybe today I'm building a work instruction on how to build the wings. Or yesterday I was working on a work instruction on how to combine the inner wing and the outer wing, what they call the wing join. So working on that area on how that whole mechanism works, so the wings fold and stuff like that. Building the fuselage, the landing gear, things like that. And also I've gotten pulled into a lot of, side jobs because I've expressed my interest in learning, where I'm now helping out with, different departments and different programs and things like that. So it's cool kind of getting my hands, I would say, wet within my first, 7 months in the company. I don't have a ton of experience within Boeing. I don't know anything with the commercial world at all. I don't know anything with the satellites or missiles or space and launch, like the International Space Station. We do a ton of stuff for International Space Station. Boeing builds all the presidential aircrafts. So there's a lot of really cool opportunities for that. And so I don't have a ton of experience with that kind of stuff, but one of my first things that I did at Boeing was get a mentor. And I've got a mentor who's actually what they call a senior technical fellow. And so he reports to basically the CEO. And so having somebody like that who can kind of, teach me all these kind of things, and he's getting me into what's called systems engineering, which is kind of, learning the back end behind why we produce a system and how that system is produced, such as, we use programming, and we use systems modeling to kind of show cause and effect, budgeting, staffing, things like that. It's kind of like learning the back end behind how we create a production line. So stuff like that is not something that I've done in my job, but it's something that I've expressed interest in learning. And so therefore I'm learning it now. So my favorite part is honestly everything that's different day to day. There is a lot of stuff that's monotonous. There's a lot of stuff that's the exact same, attending meetings, talking to people, things like that. That's the same. That gets kind of boring. But it at the end of the day, it comes down to what you want to do and how much you want to learn. And you can always make time, and people will always make time to teach you something new. And so that's kind of something I've extremely taken advantage of these past few months. The thing that I like the least, honestly, I was kind of spoiled coming from the automotive industry, in that the automotive industry is so what they call lean, meaning all of the waste and all of the time that is in between different steps and things like that has been eliminated. So if you look at a production system, they are pretty much as perfect as it can get. They're producing 400, 500 cars a day, right? Versus Boeing, who maybe takes 3 days to put a wing together. You know what I mean? Something like that. And so what I'm getting into is all of the BMW plants that produce all the different models. They use the exact same software. They use the exact same models. They have the exact same teaching style and management style and things like that. At Boeing, it's all different. Different programs have, so say the F-15 fighter plane has different software than the F-18 fighter plane has. And the satellites have different software than commercial has. And things like that. So everything is so different. And so for me to transition from my job to, say, a job with working on the 787 or the 777 or one of the big passenger planes, it's going to be a really steep learning curve to kind of learn how they do things versus how I've done it in the past. And that's something that is really difficult. It's not easy to do. And especially when you want to jump in and learn and do stuff right away and contribute, and you can't because you don't know how to do things and you don't know who to talk to. It's tough. And that's kind of the thing that I guess has stressed me out the most and made me not like my job the most, is the fact that everything is so different. And the job that I'm in right now is in the production engineering core group is what they call it. So people on our team, we're supporting people, or we're supporting the products in Philadelphia, making helicopters and satellites in California, and what they call commercial derivatives. So taking a passenger airplane and making it into a military aircraft down in Texas, and International Space Station down in Texas or in New Orleans. And we support, you know, programs everywhere. And so getting put on to help support a new program and having to learn what systems they use, who to talk to, and things like that is really frustrating. And that's something, you know, that they don't teach in school and you can never learn. So it's kind of learning how to adapt. I would say adaptability is really tough. And it's something that, you know, you learn from internships and from jobs and things like that. And from classes, you know, going from being in person to working virtually is huge. Like little things like that is something that could make transitioning like that easier. And then that's something, like I said, that you have to learn with experiences. So get the most experiences you can, and that'll help out in the long run, ultimately. Does anybody have any other questions?
I think that's all we had. Thank you so much. That was really helpful.
Yes, thank you very much.
Absolutely. And I'll have Emily provide my email or phone number or anything like that. And you guys can contact me, reach out, send me an email, I'll schedule a call with you or anything. We'll talk through it all.
Perfect. Thank you.
We can establish a mentorship if anybody wants, you know, just help getting through classes, or, you know, which path to take in college, like little things like that. It's always easier to talk to somebody who's been through it and to somebody who, you know, has those life experiences. So absolutely, if there's any questions that pop up, whether it's what classes to take, what school to go to, anything like that, feel free to reach out and we can talk about it.
That's really helpful.
Absolutely. And two, with robotics, if you guys need any robotics questions or anything, I'm always available. So I don't do anything usually on nights besides the gym. So reach out and I can hop back on another Zoom call and we can talk more about it.
Yeah.
So absolutely.
Yeah, thank you very much. Yeah, would it be okay if we contact you later when we get like some more of the robot done?
Absolutely.
All right.
Yep.
Thank you very much.
Emily should have my email, and put it in your guys' Google Docs or whatever, and shoot me an email whenever.
Yeah.
All right.
Awesome. You guys have a great evening. I appreciate your guys' time.
Thank you. Bye-bye.
Take care. Bye-bye.